棒のトマト棒のトマト棒の棒のトマト赤上げて緑下げてトマトマトマト
Black Swan. Hi guys, let's talk a little bit about this black swan phenomena. We know modus tollens says if P then Q, not Q, then therefore not P. So on a globe, the globers say that we can calculate the distance to the horizon based on a formula, and for this to happen the horizon needs to be a physical location, so we need to have a geometric horizon. So I marked here on this globe with the red tape the so-called edge of the sphere. We see it, okay, and we're gonna try to see if we can see past it. The globers invoke refraction, right? But we know any object that goes past that horizon line needs to be physically obstructed by the so-called edge of the sphere. Okay, then let's see what we can do. So if they claim refraction, that means difference in temperature, atmospheric conditions, and so on. Right, so we're gonna try to see if we can refract the horizon from behind the horizon. Okay, so we're gonna heat up the air a little bit and see what happens. Something's happening. Looks like the horizon is refracted from behind the horizon, but let's take a closer look. Let's see what really happened here. It's just because of the hot air, the ball just expanded and it bulged up behind the tape because the tape was constricting the material, so it looks like it just bulged up because of the heat. So this doesn't say anything except that the material. So globers, don't get your hopes too high that fast. Okay, we can see clearly here how the plastic material just bulged up and made a groove there. It's like a mountain rose up from behind the horizon. So let's talk about something else now. On a flat surface, the distance that we can see, how far we can see, the distance to the horizon is dependent on visibility, and now we'll check. I think it's time to go on a diet. We'll check. Let's see if we say that this bounty towel represents the atmosphere and it shows us the visibility. So we can see that on a flat surface, based on visibility, the distance to the horizon can change. So we can see farther or less far. Now let's check this on a sphere, so we can see the so-called edge of the sphere there marked by the red tape. And based on visibility, we'll check now, we can only see up to the so-called edge of the sphere. So the horizon can be closer but not farther. Yeah, let's try that. Here we see, if we say that's the atmosphere representing the visibility, let's say it's fog, visibility is 0, whatever, then we have a clear day, we see up to the horizon, then we have extra good visibility, but still we cannot see on the sphere farther than the so-called geometrical horizon, the edge of the sphere. Okay. So that's clear. No matter how good the visibility, we cannot see farther than the horizon, which the globers need it to be a geometric horizon to calculate the distance to it based on a presupposed r. There we go. The horizon can be closer than the calculated distance, but it cannot be farther. Okay, now let's try with some different material here, because that plastic ball just bulged up from the heat, and we're gonna see if we can refract the horizon again from behind the horizon. Let's put an object that's obstructed by the horizon, physically obstructed. Okay, there we go. Let's turn the heat on. There we can see that the object that's behind the horizon is a little bit, the image is distorting a little bit, but there's no horizon rising from behind the horizon. If I don't know, the globus maybe try to use some butane, maybe you get a different result. As it looks right now, there's no horizon rising from behind. So the geometric horizon that we have here is not the same as the horizon in the real world, because we can see farther than the calculated distance to the horizon. Of course, it's apparent only, so you cannot calculate the horizon, the distance to the horizon, to an apparent location, because you don't know where that location is. And here we see again with the visibility, the horizon can be closer than the edge of the sphere or the geometric horizon, but it cannot be farther. There we go. Okay, so here we see the object that was obstructed by the geometric horizon, and when we applied heat we see that the image distorted. It's still only the horizon marked by the tape over there. There's no horizon behind it. So there you go, guys. Bye bye ball. Have a good day. So until further notice, welcome to Flat Earth.
これねセラトマト